Okay, so we're going to take a look at example 4 on page 89. Hopefully you've at least made an attempt to do this example on your own, okay, before you watch this video. They'd like us to give a formal proof that the series that we're looking at the right here diverges. And this argument, the structure of it is going to sound very similar to the one that we wrote for example 3 above, just that the calculus that we have to do is maybe a little bit more complicated. All right, so we're going to use the test for divergence, just the same as we did in example 3. So we'll start by taking the limit as n goes to infinity of the nth term in our series. We're hoping that when we take that limit, we get something that's not 0, because then, if it's not 0, we can use the test for divergence to conclude that the series diverges. All right, well, you can look at that limit and see that we're approaching infinity on the top and the bottom. Okay, so we're free to use L'Hopital's rule. So if we take the derivative on the top and the bottom, we're going to get e to the n in the top and 3e to the n plus 1 in the bottom. Notice that this new limit that we've got is still infinity over infinity. The top and the bottom are both going to infinity. So we can use L'Hopital's rule again. Take the derivative one more time on the top and the bottom, and we're going to get e to the n over 3e to the n. The plus 1 is going to go away. And now, notice that because that plus 1 is gone, we can actually do some cancellation here. The e to the n's go away, and we are left with just the number 1/3. And what's nice is that that number 1/3 we got is indeed not equal to 0. And so, by the divergence test, the fact that that limit is not 0 allows us to conclude that the series diverges. Okay, and there's our proof. And I will make one comment. You might have noticed when I wrote this summation symbol over here to the left, I didn't bother to write n equals 1 to infinity. I could have, but a lot of times, just to save ourselves a little bit of time, it's okay to leave off the n equals 1 to infinity. Okay, so